Hello, everyone, and welcome to our beta update webinar. I'm joined today by Chris Anthony and Steve Fambro, our co-founders of Aptera Motors, as well as Jason Hill, Aptera's designer. And I'm Sarah Hardwick, our Chief Marketing Officer. And today we'll be discussing some of the updates and enhancements that we've made to Aptera during our beta development phase, which has happened over the past 18 months. And we have a lot of new information that we'll be sharing that's never before been seen or discussed. And we'll also be taking quite a few questions from our fans over the course of the next hour. So we hope you enjoy what we have in store for you. We're going to dive right in today. And we're going to talk a little bit about what you'll be seeing. So over the next hour, we have quite a few new features that we're going to talk about in detail. We're going to talk about how we've added some additional interior and battery packaging room through our AI generative aero improvements. And Chris will be talking about that. And we'll be talking about with Alafe how we have enhanced our motor efficiency and packaging. And also we've come up with a brand new body part breakup, and that will be assisting us to ease assembly and assure better tolerances. And a very new and exciting announcement we'll be having on our website later today. We'll be posting an announcement with Roush, who's a leader in engineering and manufacturing and testing and prototyping. And we've been working with Roush to evolve our suspension to improve stability, to improve turning radius, as well as performance. And we're also progressing very quickly with our battery systems, with our solar, with composites, and all other systems with our vendors and design partners. So Steve will be talking a little bit about that today. And last but not least, we've dramatically improved our driver and passenger ergonomics through several interior and structural changes. And Jason will be speaking to those changes later today. Lots to cover. Let's see here. Okay, so just to give you a little bit of background, as I went through, we had honestly hundreds and hundreds of questions that were submitted from our fans and through social media. And probably the biggest one is, where are you guys at in production? And when can we expect to see our Aptera vehicles parked in our driveway? So we thought it would be helpful just to reinforce and kind of give you some background on the stages of vehicle development that we have here at Aptera. So the first stage, which we're in, have just completed, is our alpha phase. And our alpha vehicles are really our learning tools. So you've seen Noir, and recently, hopefully everyone's headed over to YouTube and checked out our new video on Soul. And then the newest addition to our alpha series of alpha vehicles is Luna, and Luna just arrived here in San Diego last week. So we'll be talking about the progression that we've made over the past 18 months from our alpha phase into beta. And what you'll see in beta is much more, production intent. So this is actually going to be what we're representing as our product. Now, when you look at alpha and beta visually, you might not see huge dramatic differences, but actually they are very significant. And that's what we'll be talking about more today, is some of those improvements and where we're at as we've moved through the completion of a lot of the beta phase. Now, as we'll be moving into gamma is the next phase, and the differences between beta and gamma will be much, much more minor. And what we have with beta will, for all intents and purposes, be very, very close to what we're going to be producing as our production vehicle when we get to Delta. So from a timing standpoint, we are still, aiming and hoping to have moved through gamma and be into Delta by the end of the year. And of course, there's a lot of positive things that could speed that up, or, there's also some challenges. So we will keep you posted. We are dedicated to being very transparent with you and letting you know exactly where we're at in this process. But as of right now, we're optimistic and pushing forward very aggressively to achieve those goals that we've set forth. So with that, I'm going to turn it over to Chris Anthony to talk a little bit more about aerodynamics and what we're seeing with some of our aerodynamic changes that we'll have during our vehicle phases here.
Hey everyone, excited to be here to talk to you about our beta developments over the last 3 months. It's been a whirlwind of a lot of activity, hiring up here in our shop in San Diego, finishing up some of our alpha builds. Hopefully all of you have seen the video of Soul, which we released yesterday, which is just so beautiful, driving along the coast and being able to finally see some of the camping features and a little more in the interior. It was a blast to just hang out with everyone and get some great video segments on Soul. Luna is coming. You actually see it in the background here. The gray vehicle, we haven't wrapped it yet, so it doesn't have any color on it. We're working on electrical and interior fitment and that kind of stuff now. So hopefully in the coming weeks, that vehicle will come together, and that will cap our alpha development. And then we'll be firmly in beta land, which is releasing tools and parts for beta to build beta throughout the summer. The intention is to get as many production parts into beta as possible, and then learn from that development and then launch into the Gamma and Delta versions, hopefully by the end of this year. Super aggressive timelines. All of our engineering partners are feeling the intensity of our efforts. We're working really hard to make it happen for everybody on this call and our over 10,000 pre-order holders. So thank you so much for everyone that has a pre-order on the vehicle. Your general support, questions, everything you guys are bringing to us is just amazing. So I was going to talk about aerodynamics first. Steve will chime in, then we'll talk about other sections of the vehicle, but feel free to ask questions in the chat, though I know Sarah and the team have gone through, I think it was 400 questions before this call. So it's a lot just to get through in this presentation, and we have those questions in the presentation so we can talk through those, but feel free to ask your questions and we'll try to answer those and update our FAQ, which has grown to be really long now. But if you have the patience and time and want to really dig deep into the details of Aptera, read through that FAQ that we posted on Google Docs to get up to speed. But aerodynamics first, we wanted to show you some great progress that we've made with our new AI generative tools. They yield some pretty pictures. Flow lines are always nice to look at. If you looked at this type of analysis on any typical sedan, it would just be really messy. You would see the lines going in every different direction, but our beautiful laminar flow, just hugs the vehicle all the way around, and really the only separation you see is on the tail. And I'll actually talk you through why we've improved that as we go through the slides here.
Chris, just for clarity, the images that we're going to be showing people are the new beta designs.
Yes.
So, and we're wrapping those designs up. We've been in beta for a long time. And so you're seeing some of the results of that.
Yeah, a lot of the beta effort was taking what we've learned from the alpha and improving the beta design. So we learned that we would like, Jason informed us that we would like some more interior room, some better ergonomics for the driver and passenger, which required us to change the shape a little bit. We pushed some headroom out, which has implications on our aero. So we actually grew our frontal area. Maybe the next slide has a frontal pic, Sarah. But we grew our frontal area by 1%. But we decreased the overall drag product of the Aptera, which is an amazing feat, to actually be bigger, but actually reduce the overall energy that it takes to push the air around the vehicle. So I think it's amazing that we're able to really zero in on these tools we didn't have a decade ago, but tools that are available today. And in a matter of hours, we can run through a simulation and optimize a certain point. But you can see on the slide here, exactly how the air flows around our very beautiful body structure here, in combination with Jason and the team here. We've worked to keep it beautiful, but optimize in every direction that we can. The next slide is another view of the flow lines around the vehicle. But you can see obviously the foil going through the air. You get high pressure above and below, and we try to keep the air, hugging the vehicle as much as possible through, every inch that it covers on land. The next slide, I think we get into some pressure gradients and pressure maps. The next slide, Sarah. This is surface friction, so it's good just to see, where stuff is getting high pressure and getting super sticky. The blue is where it wants to pull away from the surface, and the red is where the air molecules are being pressed very well. The next slide is a pressure map that shows it a little better maybe. But you can see obviously the nose and the front of the wheel pants, they take the brunt of all our aerodynamic hits. You can imagine if you were looking at this aerodynamic analysis of an F-150 pickup truck, the side view mirrors would be big and red. And the total aerodynamic drag of the whole Aptera is less than just the side view mirrors of an F-150 pickup truck. So it's pretty amazing that this whole vehicle that seats 2 passengers side by side, that's as wide as a Model S and as long as a Prius, is like you driving down the freeway in any car and just sticking 2 of your hands out of the window. That pressure that you would feel at highway speeds against your hands if you stuck them out of a car window, that's what the total drag product of the Aptera feels like. So it's amazing how little energy we have to use to push air out of the way. And
it's for a big shape too. I mean, you can camp in it, you can put stuff in it, you can sleep in it. So you're bringing this big shape along with you. You're not in some tiny little car. You're in a pretty big vehicle.
Yeah, I think the improvements that we've made, on the ergonomics and everything will suit almost everyone except maybe Shaquille O'Neal. We may have to make a special seat for him, but lots of interior room, and to get that kind of packaging and still keep the drag product that we have is amazing. On the next slides, I think we get into some noise analysis. The slides with the purple, Sarah. Yeah, interesting thing in our analysis is looking at noise. Noise is often indicative of where things get dirty. You'll notice we've added side view mirrors in this analysis. And we have some regulatory requirements that require us to have mirrors. We would love to not have mirrors because, as you see, that adds to our total drag product. But we're talking about some asymmetries and some way to streamline that. But that's an analysis that's ongoing. The areas of improvement still to be had, I think, are really in the wheel pants and the suspension. Steve will talk a little more about some of the refinements we've made with Alafe in the coming slides. But really, the front wheel covers and the suspension in between those wheels are areas of interest for the next month or so as we start to wrap up our beta design and release all that tooling. Maybe there's a better view in the next slide, Sarah. There you go. You see that area between the front wheel cover and the body. Air gets smushed between the front wheel pant and the body, and that's one of the biggest areas of drag for our vehicle. If we got rid of those front wheels and had some propulsion system that just allowed us to float, we have amazing aerodynamics. But unfortunately, you have to have rubber on the road. So that'll be our next focus. But everything's coming along great with beta development. So we wanted to talk with you a bit about. This is a good picture showing you kind of how that air is funneled between the body. It looks just like a big funnel between the body and that wheel pant. So things get ugly behind the suspension and the back of the wheel pant. So we're working hard to improve that. The next slide is.
Sorry, just even things are ugly, but we're still at a drag coefficient of 0.13. So for us, it's ugly. We want to improve upon that because we see opportunities, but it's comparatively speaking.
Comparatively speaking, we are beautiful, but we definitely want to see improvements there. This GIF is an interesting analysis. I don't know if it's actually playing though. I don't see it moving here.
I don't think it's moving. I'm sorry, Chris. Doesn't look like it is here, but.
Anyways, this boundary layer, the layer that you have in red there, is actually a way for us in fluid dynamics to let the computer do the work of optimization. And when we put this model In the computer, we can let the AI generative design take a look at a boundary layer, and it'll say, this is what you should do to make this more aerodynamic. A lot of things that we've done over the last years have been very counterintuitive. I'm a fluid dynamics guy from hydrodynamics, and Steve's a pilot for the aerodynamic side, and things that we kind of intuitively say, oh, we should do this. We do that, and then we put it in the computer, and the computer says, no, that was bad. And then we start over.
Yeah, just to be clear, what we were hoping to show you was this animation where you could see the computer actually iterating through and adjusting the shape to minimize a drag. So it's something that 10 years ago we couldn't have even imagined. But now it's done literally in a matter of clock cycles. But unfortunately, animation is not working. It's business presentation.
What it was doing was it was telling us to smush the tail. So it said smush the tail down more at the top than at the bottom. So we did that, and we iterated that design, and we greatly improved the tail turbulence of the Aptera, while still keeping all the mechanical properties of the full body that we needed. The next slide was another example of the rear wheel skirt, something that was not intuitive to us at first, but that the generative aero design showed us was that the peak that comes down of that rear wheel pant, we thought intuitively, it should cut the air like an airfoil, like an airplane wing. But that is not what the computer was telling us. The computer was telling us, no, let the air, it's a lower pressure region, let the air flow around that rear foil more easily. So it actually took that corner and pushed it all the way in to kind of line up with the rear tire, which, it was counterintuitive, but, it made, a percent gain for us in overall drag improvement. So it was great to see the computer do that work and then go, oh, okay, all right, let's do that. And then we'll retest it. And it worked out well. The last slide is some of the front wheel cover work that we did. And the computer was telling us basically to not compress that air between the body and the front wheel covers as much as possible, and to move those points on the wheel cover adjacent from each other to decrease the pressure between the body and the wheel cover and release that pressure behind the wheel pant, which I think is just great feedback for the computer to be able to tell us, look, this is the direction you need to go, and then we follow that direction, and Jason can mush and meld it and make it look beautiful, and then we end up with a beautiful looking foil that does everything we want it to do.
Yeah, in this picture, I think you see the starting case, but the ending case, it would be a little bit asymmetrical when it's done, which is counterintuitive. But
to Chris and Steve's point in regards to the aerodynamics and the tools, it's fascinating from the design standpoint to use that AI generative, suggestions and see how close it matches either the intuition or the kind of instinct, let's say, from either an aerodynamic or a shape standpoint. So it's really been a great validation tool and allowed us very quickly to iterate, like Chris said, in a matter of hours. We can present a new model, run it, and find out what worked and what didn't. So we're very close on wrapping up this beta body, and it's an amazing feat from a design standpoint to increase the size and ergonomic functions while decreasing the overall drag product. And we're really pleased with the optimization tools that we'll be able to bring to this.
We have to throw a shout out to Jeff Bezos. Thank you for Amazon Web Services. Instead of having to build a computer cluster here that would have cost us tens of thousands of dollars to run these simulations, now we can just upload it to Google's cloud servers, and within a matter of hours we have the results that we need. So it's a great flexible use of compute power that we just didn't have before. So it's great to see that iterate quickly and get the results back quickly. We had some questions we were going to go through. Steve and I can answer, and then Steve was going to talk about some of the drivetrain enhancements. Do you want to ask the question, Sarah?
So the first question we have is, Sure. So first question is, so why did you decide to put the rear view cameras on dedicated stalks? Could they not have been embedded in the front wheel covers instead to improve aerodynamics?
We've had that conversation and battles internally many times. It seems like, gosh, the front wheel covers would be a great place to have them. They're mostly pointing backwards, but as you turn the vehicle, the wheel covers move. So that makes it more difficult. We did have originally a design for cameras in the body, so everything was flush and conformal with the body. But the problem is you need some digital stitching of the image and some image correction that is a pretty hefty lift on the development and firmware side. And we did not think that within our timeline that we would be able to execute on something like that. So putting the cameras out on stocks, getting them away from the body in a reasonable fashion just seemed to be the best of all options for us right now. Hopefully in the future, we can improve aerodynamics and maybe have the cameras.
Yeah, we'll be able to show, I think, the government officials how many tons of CO2 we'd save by pulling the mirrors, deleting the mirrors and just simply having the camera. So we'll be able to show that calculation. Maybe that might help them understand.
Yeah, and further, I mean, it's a very simple thing, because if the wheel pants were fixed, that would be the best place for the cameras. But since they're active, unless you're on a very steady state of smooth road, you're going to have a lot of vibration, natural vibration, just through the springiness of the tire and suspension. So you can't get a relatively smooth feed into it. So by putting them on the stalks and also combining them with a small mirror, we can hit all those metrics of good aerodynamic performance, regulatory compliance, and we're evolving. We're looking forward to the day when the U.S. catches up with other jurisdictions and allows full cameras instead of a mirrored surface.
Great, thank you so much. Here's another suggestion / question from one of our fans who says, golf balls are dimpled to reduce air resistance. So would dimple on the fenders or the fairings help?
Well, the dimples help trip they generate turbulence and trip the boundary layer, and so there's areas where you need that. It's not apparent to us at the moment where on the vehicle that would benefit from, although there are some areas that would benefit from different surface treatments. So there's something similar being discussed for certain areas of the vehicle.
We talked about the kind of usability of a textured surface, and the problem with golf dimples or anything is it would have to be quite deep to have an impact on such a big body like ours. And if it was that deep, then washing your Aptera would get to be a challenge, because you would have little crevices everywhere where dust and dirt would like to collect.
Yeah, and further, and not that a golf ball pattern or the dimple pattern is ugly by any means, but golf balls are active. They spin. They're not static to the air. So that's the main reason. You don't need to have these dimpled surfaces in order to get good aerodynamic benefit.
That's right.
Thank you. Any reason that you're keeping the payload limited to 500 pounds?
We're very weight sensitive. So after Thanksgiving, when you come back home with more weight in your belly, you're going to take an efficiency hit in the Aptera. It works out to about for every 30 pounds, you gain or lose 1% of range. So, we're more sensitive to weight because we're going to be the lightest weight, most aerodynamic, most efficient vehicle out there. So limiting the payload capacity is just something that will assure that you get the kind of range that you're expecting.
And handling as well. I mean, the ratio of the sprung mass changing with an additional 500 pounds is a much more complicated thing to handle with the shocks and springs set up. So there has to be some limits, and that's a comfortable limit for us.
If you have a big electric vehicle that weighs, 5,000-ish pounds and you add 500 pounds, it's only a 10% weight differential. If you have an 1,800 pound vehicle like the Aptera and you add 500 pounds, it's a lot wider spread in how the vehicle dynamics work, the dampening, the spring rates, that sort of stuff.
So one more question related to weight reduction. Actually, I think the next two questions are related to weight reduction. Please tell me you won't chase a few pounds of weight reduction by opting for scratch and UV prone polycarbonate over glass windows.
Did
Please.
you write this question? It's an ongoing discussion we've had. So first of all, no, the active plan is automotive glass in every window. So that's the plan of record. In a parallel process, are we looking at different coatings for polycarbonates? Maybe for certain areas, it's being looked at, but the plan of record is glass.
Right. And the last question for this section, how does the addition of optional solar cells affect curb weight?
It's interesting. You would think that the solar would add a lot of weight to the vehicle, but the full solar package with solar cells all over the vehicle, those solar cells only weigh about 4 pounds. They're very, very lightweight. So the weight impact of adding the extra solar on the rear hatch or getting the hood solar is very, very minimal. We have to have that composite structure there for a hood or a hatch anyway. So you're not incrementally adding a lot of weight.
That makes sense. Okay, I think we're ready to move into the next section, which is the Elaphe drivetrain. And Steve's going to give us an overview of some of the key changes that have been happening in this area. And then we'll go through some images and we'll address some questions. So go ahead, Steve, and give us an overview of what's happening in beta with our drivetrain.
Well, from a big picture perspective, when we first started this endeavor, and talked with Elaphe, we basically got things that were off the shelf. So motors that were in current production, inverters that were in current production. And we said, as part of our feasibility study, let's just integrate them in with our design and see how it goes. And of course, it's been an overwhelming success, right? We've been able to free up the body and the structure by having full autonomy of movement inside, because we move the powertrain basically to the wheels. There's no drive shaft, no CV joint, no gears, anything like that. Everything's in the wheels. So that's been a profound success. But early on, we realized that the size of our vehicle, the reduced power needs, and the different speed regimes and everything that it operates in, we wanted to fine tune the efficiency with the Elaphe. And so that involves some elements of the motor design itself, in terms of the magnets and segmentation, the speeds that it was most efficient at versus from the off-the-shelf unit. And in particularly, we wanted to save further weight by not having to attach different elements to the wheel, but we wanted the wheel motor, but we wanted the wheel motor to have those attachments built in. So our ball joints and suspension connections could be made directly into the wheel, rather than into an upright, which bolts into the wheel, which is what we have on the Alphas. And so part of the big development of beta has been to reduce the weight of the motor, to tune the efficiency band more towards our operating regime at Aptera, which is a lower load and a lower duty cycle, and to improve the suspension geometry by moving the center of rotation of the wheel more inward by having the attachments directly on the motor. And one of our engineers, Carl, has been working with the Elaphe team extensively since he onboarded on that particular matter. Let's look at the next slide. I should also add that, part of the product offering that we have is the two-wheel drive and the all-wheel drive. Personally, I like the all-wheel drive because it's more power. The two-wheel drive is very fast. It's much faster than my Bolt. So I like that one too. But from early on, we weren't sure how the vehicle dynamics would be with two-wheel drive versus all-wheel drive. And so part of the alpha development was just to do the feasibility on that and say, hey, they're both viable options. Some people want to pay more for the all-wheel drive and get that extra power and acceleration. Most people are probably going to want to opt for the two-wheel drive and have increased efficiency. So one of the biggest things that you'll see different on the beta, if you go back to the other slide real quick, is if you look at pictures of the Alpha now, you see the orange power cables exposed. That's not our intention by any means. The aerodynamicists in us cringe, at the idea of the power cables being in the free stream. You'll also notice the Alphas don't have any aero covers over the arms. and other things like that. And that's all part of the Alpha plan. There was no intention to do that. We realized early on is that because of our lower power needs, we could use smaller cables that were more flexible, smaller diameter, and able to be packaged better, but also that we needed to change the orientation of how the cables come out of the motor and other things like this. And that was more complex than what the Alpha program intended to be. So that's why it was pushed to beta. So that's one of the things that Carl and Lafe have been working on. And so you'll see now the cables will the cables will exit the motor at the bottom and be able to be packaged in the control arm aero cover, which is unlike what you see on the Alphas now. Next slide. So yeah, being able to connect, I don't know if you can see the geometry markers on the line, but the control arm goes much further into the motor because it connects directly to the motor with the suspension attachments. Whereas in the Alphas, it's actually outboard an inch or so because of the upright. So it's improved geometry there. And then can you speak to the rear wheel changes?
Yeah, the rear wheel is the same thing, just optimizing the wheel to attach to our swing arm. Lightweighting the rear is even more important than lightweighting the front of the vehicle. So we're spending extra time in our rear suspension development to keep things very nicely packaged and as lightweight as possible. The next slide, I think, shows a bit of the aerodynamic challenge.
Yeah, so you can see the improved geometry here. In fact, I think it looks like is that an accurate image? I can't tell.
Yeah.
So we have the AR cover, the arm covers modeled in there, and you can see sort of the range of movement. That's why the ball joint sticking out of the bottom.
The next slide shows the upper arm cover a little better. Yeah.
Right. So this is all something we couldn't do with the Alpha because the geometry just wouldn't allow it. So by changing the geometry, working with Lafe to account for our special needs of the Aptera's geometry and suspension and the width and everything else, we're now able to package the A-arms with a nice little flexible cover and reduce the drag and get rid of some of that noise that you saw in some of the earlier software models.
And anything else before we head into questions for this section?
Nope.
All righty. Oops. There we go. So first question, how will the car run if one of the motors fails?
Should run just fine. We've actually done that test already. We've changed the three-wheel drive vehicle to operate on one motor, different wheels, just to do some basic validation. Would it be treated as a limp home mode or some limited performance or something like that? That's all to be determined. But yeah, you'd still be able to drive the vehicle with only one-wheel drive.
How about tire pressure monitors or self-sealing tires?
We'll definitely have a TPMS system that will tell you what your tires are running at in any given moment. It is extra crucial for us because we're so lightweight and so efficient that you have the tires at their proper pressure. I haven't seen any self-sealing tire technology that doesn't come with a weight penalty, and sometimes a significant weight penalty. So we aren't really looking at any self-sealing tire technologies because it just adds too much weight to the equation.
Makes sense. Will production model have autonomous driving or at least semi-autonomous driving?
We're working on that now. I mean, we're talking with 3 different partners, and we've got all of them have either some off-the-shelf solution or an existing solution that would be integrated into our vehicle. And they all have pluses and minuses, but our goal is level 2. And it's not full autonomy. We never wanted that. That's a whole different endeavor. For us, the level 2 autonomy is more than enough to have to launch this vehicle. Will we do more in the future? Who knows? But that is part of the plan. If we can execute on that, that'd be great. We're working to do it.
The biggest challenge now is a sensor package. There's so many different variants on ADAS and autonomous vehicle controls. that zeroing in on the right solution for us and moving forward, is something that we're actively working on now. Brian has great experience with Andromeda interfaces, and he brings that to us to get us on the road in style. But with 1,000 miles range, it would be great to know that your vehicle has a lot of autonomy.
Yeah, the demo that we had last week or two ago here in San Diego was phenomenal. We'd be more than thrilled to have that solution in our vehicle.
We have a lot of Teslas here, so we are very familiar with a lot of Teslas and Bolts and every electric vehicle you can imagine almost now. But benchmarking those systems has given us a great affection, especially for lane keep and adaptive cruise control.
Thank you. So we have Aptera fans all over the world, and lots of climates that are not so friendly, not as nice as San Diego, certainly, and some weather. So San Diego specifically, is a salt air location. So how will the drive chain components perform? How durable will they be in these salty conditions, or even conditions where there may be, roads, snowy conditions with salt on the roads, things like that? How will the drive chain components perform in those circumstances?
Our co-founder, Michael Johnson, lives in Corpus Christi, Texas. And he says anything metal that you leave out for more than a week will fall victim to Corpus Christi salt. So we're very attuned to the need to have a very robust solution. And I think Alafe's done extensive testing on that. And our engineers have a mindset to make sure everything's, has a great longevity in salt conditions. An amazing thing about a composite body, don't have to worry about it rusting away.
Yeah, and I think one of our last webinars we did with Alafe, they were asked that specific question and addressed it. And yeah, the salt mist, salt water, it creeps everywhere inside the vehicle. It's unavoidable, but it's not apparent to us that it degrades the performance or longevity of that motor.
Yeah, there are some great YouTube videos on the Alafe's YouTube channel, also a website, that show a lot of the durability testing they've done and a lot of the environments that are very rugged, such as salt air locations. Thank you. What is the energy expenditure difference between the 2-motor and 3-motor versions?
I don't know the number, but it is a difference.
It's about 10%. If you wanted to flatline it, there's some nuance to that equation, but the 3-wheel drive uses about 10% more energy than the 2-wheel drive version. So all-wheel drive gets you more power, gets you great torque vectoring between the front and the rear. So, if you live in snowy, icy climates, it may be, that you just really want all-wheel drive. But the most efficient drive package is the front-wheel drive. It's about 10%.
Yeah, and that's without any optimization at the moment. So, for example, one could imagine, selectively turning off the rear motor and making sure, reducing back EMF or whatever, so there's no parasitic losses. We haven't even begun that development yet. So the 10% number is just as it is right now.
Yeah, if you use all wheels equally for power.
Thank you. Well, I think that wraps up the drivetrain section questions, and we'll be moving on to body breakup, which we'll go back to Chris for a summary of what's happening with the body and some of the major changes that we have been implementing and are now nearing completion in our beta phase.
Yeah, Nathan and Greg and our structural team have made some great advances on our body structure and breakup. Even stronger, even easier to build, but it is a bit different than how the alphas came together. And I think we can kind of quickly go through the 3 different slides that Sarah has here, and you can see the tub, and then the tub gets a rear closeout to close out the rear storage area and give you lots of nice storage. The rear storage area is actually dropped a few inches too, so we have more internal storage. And underneath that black panel, you have storage underneath that panel between that and the floor, enough to fit, a week's worth of camping gear. And the next slide shows how the top comes on. Everything kind of keys together like Legos. Everything's human positionable, which is nice. So 2 people can lift up any body panel, take it to the assembly floor, the jig where it's bonded together. And there you go. You have, the the world's strongest, composite vehicle structure for a three-wheeled solar-powered EV, right? We hope to increase the roof crush strength greatly from where we were at before, including side impact and all those other nice metrics. But it's been a delight to see how the structural engineering has come together.
And just to be clear, where we were at before exceeded the FMVSS for passenger vehicles and exceeded at the time the roof crush strength of any passenger car sold in the United States.
Yeah, it's only the best vehicle structure ever created.
I agree.
Some questions on this topic, Sarah?
Absolutely. Always lots of questions. Okay, this is actually from one of our ambassadors, I know, and he's wondering, he's been planning out his garage space probably for over a year now, and he is wondering, is that still accurate to plan for a footprint of 88 inches wide? He wants to make sure he can get in and out of not only his garage, but tight parking spaces. So is that still the plan?
I would plan for a 92-inch entryway, just to give you a couple inches of sway. We'll have sensors on the wheel pans to tell you how close you are, but I think 92 inches to get in and out seems kind of like the minimum that we look for, like in trailers and where we're going to park and everything. 92 inches is nice, but the vehicle width has not changed. We may be able to bring that in a little bit, but probably not more than an inch. So I would plan for 88 inches.
So 92.
92 inches to get in, but the vehicle footprint is 88 inches wide.
Yeah. And I think, as we always get this question a lot, so as it relates to our international customers, of which we have many, we are aware that there are some regions where Aptera, currently is too wide to be, according to those local regulations. So we are committed to bringing Aptera. We absolutely will be working with partners and looking at some potential design modifications to make sure that we can make Aptera available to you in your country. That will definitely happen after we have our main vehicles into production and we get that process rolling. But it is certainly our intent, and we want to make Aptera available everywhere in the world. And we hear you guys on the forums and the blogs and our social media, and we are doing everything in our power. So just know we got your back, and we want to make that happen just as much as you do. So
we have homologation experts working on that now, and there are some exceptions to some of the EU rules that get us in as an automotive but low volume brand there. Right. So I think there's ways to make that work in the near term over the next couple of years, as we really get to scale production and start to make other kind of variants that are applicable to North America and Europe.
Okay. So next question. So for beta, will there be any sort of removable or optional third seat in this three-wheel version?
No, we've looked at it, and we had that option before. And when Steve's daughter Phoebe was just a baby, it was great to see her clipped in the back of an Aptera in the car seat, and that may be an option in the future. But we've asked fans several times, and it seems like a very, very small percentage want that third row seat option to start. So to decrease the engineering hurdles for us, who decided just go with the two seats for now, and we'll make a variant in the future that might have that option.
Next model year or next variant.
Yeah. Yeah, our goal, as you all know, is to create a fleet of solar electric vehicles, and there'll be many other versions and many other types of vehicles with more seats, more wheels, most likely in the future. So never fear. Okay, I'm concerned about corrosion resistance. What's planned for the attachment points that are embedded into the main body structure, the composite portion?
That's a good question.
Yeah, we've done a lot of testing on different hard point strategies and corrosion studies and pre-treatments for how we do that, and nothing seems to be an issue with corrosion in those materials. Once they're embedded in the composite, they're there for life. We're talking about different materials in the suspension that can obviously stand up to generational use of the Aptera. So that's our goal, is to have a very long-lasting vehicle that can stand up to salt, that can stand up to rain and ice and mud and anything you want to throw at it, and something you can pass down to your grandchildren at some point.
Yeah, it's not a simple issue. I mean, there's material science, of course, involved, and work that's being done on that to make sure that you're going to be able to have that long life cycle out of the vehicle. But yeah, those things are being addressed.
Speaking of things, elements to withstand, how about strong gusts of wind? So will the Scarab style doors be able to withstand strong gusts of wind without frame damage?
Better be.
Yeah, we'll talk about our new engineering relationship in the next slide, but we've actually been working with Roush Engineering on the door systems, and it's a question that's come up as we've been working on the upper and lower door hinge and the strut strategy. How to in traditional automotive terms, have good wind resistance with our doors. It's actually easier for us with our Scarab style doors than a typical passenger door, because typical passenger door opens flat. So you got a lot of area for the wind to hit that door and push against the hinge. If you have a door with some tilt, it's going to move the air around it. So even if you take a lot of gusts, it's not nearly the pressure pushing against that door as you would have in a typical automotive.
And the attachment points are wider too. So that makes the loads much less into the vehicle.
Yep.
Correct.
Okay, great. Moving on, Chris mentioned Roush. And as I said earlier, stay tuned or head over to our website later today, where you'll see a press release that we'll be putting out announcing a relationship that we have with Roush. We're very proud and excited to bring them on board as one of our key collaborators in this process. So Chris, maybe you can give us some background on what's been done and some of the key changes. I know this is a major area of focus for us that we have really made a lot of enhancement to in our beta phase.
Yeah, I'll try to make it quick too, because I see we're taking a lot of time. An hour runs quickly. But Roush has a storied history in performance engineering and race. They've done a lot of great things over the years with Ford and other big automotive brands. They have come in and they've really helped us with a world of part supply knowledge and how to get our vehicle suspension ready for production. We have some animations of some of the work they've done with their Adams models to tell us how our suspension will perform in on-road conditions. The first one is our turning radius. Improving our turning radius has a lot to do with, how your suspension is positioned, and our in-wheel motors have some unique challenges. So getting that right has taken some effort, but we've improved the turning radius and then moved on to other suspension efforts. We'll see if Sarah can.
I'm going to see if I can, and we'll just for everyone, all 632 of you, thank you for joining us today. We're going to be sending out this deck that will have the animations that we discussed in it. We're having a tiny little technical issue, but we'll make sure that you guys get this deck so you can see all these videos and things like that. But hopefully this will come through okay. This is what Chris was describing here.
Scrub is important between the inside tire and outside tire, and how your suspension is set up makes all the difference, and, kind of parking lot feel.
So looking at alpha and beta?
Yes. Yeah.
So you can see that the beta improvements in beta are the improved turning radius, which is visually apparent there.
The next slide is talking about some aggressive lane change scenarios. Where this was actually an analysis done at 75 miles an hour. But if you guys saw our track video where we went out to the Verona Raceway, we did some very basic lane change scenarios at 45 miles an hour. And we were seeing some wheel lift on that. Working with Roush, we've really cleaned things up. We've added a sway bar, which gives us added stability. We had hoped we wouldn't have to add a sway bar because it is extra weight. but it makes a world of difference in how the vehicle handles. So at 75 miles an hour, to be able to aggressively get out of the lane and back into the lane, I think it looks beautiful.
And absolutely no wheel lift either.
Yep, absolutely no wheel lift. The next scenario was a similar view to the last one, but just to show you kind of the kinematics of how that works. Staying center line in your lane, and then having to move out of that lane because there's a deer there, or there's a moose, or something else, some ladder that got dropped on a California freeway, and you got to get out of the way and back in the lane. But I think that one plays too. Anyways, it was kind of the same simulation. But questions on this?
Sure. Do you want to talk any more about the performance on the track? I know we've taken now both Noir and Soul out to the track, our alpha vehicles, to validate a lot of the design work that has been done in beta. So can you give us any updates or anything you want to share on that?
I think in general, Matt and Dan and the team have been doing just great work getting the vehicles out on the track and proving them out. I think the general consensus amongst the team is that the vehicle feels very well grounded. The extra sprung weight on the wheels, I think, gives you a little different feel for the CG of the vehicle, but it is performing beyond expectations that we had hoped for from Alpha. And now working on these great improvements with Roush, the betas are going to be even better.
Yeah, I mean, the what we've seen with Alpha really raised no flags, but we were already well underway with the beta development by time we were getting those data. And so when we go back out to the track with the beta vehicles, it's going to be to Buttonwillow and other more performance-oriented venues.
I hate to say that we should skip questions here, but we should give Jason some time.
Okay, let's do it. I know we want to talk about interior and ergonomics. That sounds great. Like you said, we will try to get some answers out to these in our FAQ, and we'll be sharing them in social too. So thank you for all of them. We've got one more little section here, and I know it's a short one. I think Steve's going to talk a little bit about batteries. Steve, anything key or new that you want to share?
Yeah, I'll be quick, just out of respect for Jason's time. So one of the big innovations that we have in our battery module is that we don't have this printed circuit board that you see right here. This was early on, even almost pre-alpha. It's a flex circuit, and that's not necessarily the innovation itself. Of course, the flex circuit is great because our battery system management system is now distributed through the pack on the flex circuit. The real innovation is how that flex circuit attaches to the cells. And the bonding time is about, it's a factor of 5 or so faster than traditional modern EV manufacturers. So what that means for Aptera is that we need fewer machines and we'll have faster throughput in terms of our pack production. So that's a real boon to us. That's going to improve the quality and also improve the throughput, but reduce capital costs because we need less machines to make the batteries.
It was taking us about 3 minutes to wire bond our first modules. Now it's taking us like 40 seconds. So great improvements, throughput.
Cool. Anything else on solar or electrical you want to address, Steve?
I'd say we're making great progress with the high voltage conversion. We've got a team working on that project for a while. And so it's going to be our own power electronics that feed from the cells directly into the high voltage pack with the minimum number of step ups and downs. So that's a real innovation as well.
Great. Yeah, lots to talk about. This is exciting stuff. Any questions you want to address? Any key questions on this battery section here that you see related to battery life post sundown, or, active versus passive? Anything you think would be, if you can pick 1 or 2 questions, maybe we'll go through.
Yeah, I'd say the battery pack cooling is sort of a hybrid cooling. There is a coolant channel, but it's not actively refrigerated, doesn't need to be. But that heat is shared or generated through a variety of systems in the vehicle as needed.
Okay. And then as far as being modular or, upgrading, is that still being determined by our team?
Yeah, I mean, there's nothing that I can say right now in beta about how that will go in the future. Obviously, those are important things. Everybody asks about them. We're mindful of them, but I don't have anything new to report.
Okay. Okay. Without further ado, I would like to bring on Jason to talk a little bit about ergonomics and interior design of the vehicle and all the amazing things that come along with the experience of sitting in Aptera, how it feels when you're driving, and the things you have available at your fingertips. So go for it, Jason.
Great. Yeah, sure. Thanks, Sarah. And I'm really pleased to see the amount of panelists. And I've been watching, just so you guys know, I've been watching all the great questions that been flowing in. I wish we could, really address a lot of or all of them, but there's some great stuff. Basically, from a high level, we started over a year ago, knowing that we were going to move to beyond the alphas. We pursued the alpha program to validate and update the ethos and the design philosophy of Aptera as a company and as a product. And now, as we get close to wrapping up beta, we're really excited that we've been able to improve in so many metrics. And we like that we can improve a little bit here and there, and it adds up over the life of the development to an overall much better result for all of us, especially as it relates to the interior design and ergonomics. We could make a lot of compromises as humans in such as getting in and out of the vehicle, but at a certain point, you've got to make it really, really the best experience for the user, for the operator. So knowing we had such a task, the results from beta are kind of summed up in the following way. We've improved the ingress egress. We've moved the H point, which is basically the automotive term for where your hips rest. We moved the H point to an optimal location. We've increased the headroom in both, let's call it the up direction and the out direction. So your basic feeling from sitting in the cabin of beta versus alpha is overall better. We don't have a big vehicle. We have a nice, comfortable cabin. But we've done such a good job, I would say, to improve and learn from the teachings of alpha and express them in beta. You can see Soul here came out very, 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 very beautiful, and it hits all of our metrics as far as what we want to learn from. We are constantly adjusting what we call our CMF, which is color, materials, and finish, to bring the best materials in there. For the best experience, the touch and the feel, how that works. Our seats are being developed to be as strong as possible and lightweight as possible, and matching all the ergonomics needs of human figures. Our UX, our UI UX has gone through a revision and an update. We look forward to really sharing like a clean, intuitive, and fantastic UI UX for that. And what else? I think that kind of hits the main points. If there's some specific questions, Sarah, or we can go back to the list.
There sure are. I love that picture. She looks like she's having so much fun in there driving. All right. Yes, we definitely have some questions. And one thing I think is so cool, Jason, is, we've been looking at renders for our vehicles for so many months. And when you look at the photo that's behind you and the one we just looked at, I mean, it is exactly like the renders that we have been producing. And I think it's really cool to see that it, just that ability to, look at side by side. It's really impressive. So good job. Question. Now, will the seats be ergonomically designed to support the curves of the back?
Yes, of course.
Yes.
Naturally so.
Okay. How about headrest? Any of the following questions that you'd like to address? Feel free.
Sure. Alpha seats, which form the basis for our beta seats, but alpha seats already have that headrest proportion, or the proportion of the seat for the headrest protection is already there. What it doesn't have in a traditional automotive sense is an adjustable headrest. So we kind of went to the place where it needs to be to protect the most amount of people.
Mm-hmm. Makes sense. How about airbags? Do we have any information on that? Maybe that might be a Chris question.
We're working with several different partners on airbag solutions. It comes with kind of a parts bin solution. So hopefully we'll have an agreement soon that has a giant trickle down to all kinds of things that we're engineering for Aptera. But we don't have something firm yet, but hopefully soon.
Excellent. How about wipers, Jason?
We expect to have a normal interface where you turn them on, turn them off. We're also looking at the auto sensor as, you know, kind of a standard way to do that. That is part and parcel. I saw a question in from the attendees. UI UX is user interface and user experience. So all of those things, how you interface with the vehicle and what's your experience when you're using the vehicle. And wiper control technology is part of that.
And then, of course, the question top of everyone's mind, what about the cup holders? I don't see them. Where does my phone go? What about my glasses?
Right. We do have ample storage for glasses, and there is built-in cup holders. We've optimized their position, location, and we're continually looking at, you know, how else to do that. I think if you've got some sharp eyes, you might be able to find some images that show those features. But we didn't add cup holders. We started with, you know, kind of an intuitive, like that's just a must. Same with phone and charging options. Same with you know, small item storage. If you look, if you can back up to the interior of Soul, you'll see a couple of those things. One is we have this add-on center console extra storage that actually has a zippered pocket, and then a pocket that we will either offer charging or inductive charging. So it won't be embedded in the vehicle, it'll be part of the accessory. Same with if you look to where your traditional glove box would be. That is a pull down, brilliantly engineered, lightweight, strong little pouch. Not dissimilar to the back of a, you know, luxury airline seat, and you'll be able to store things in there. And we did that in the interest of, and it really goes to the whole ethos of the interior design. Instead of engineering a hinge and a latch and a seal and a lock and everything, we put everything of convenience more on the top of surfaces. This will allow upgrades. This will allow, you know, tooling changes, in the same manner that the screens are not embedded in a large form, and that they will be able to quickly iterate, or as screen technology progresses, we'll be able to change those out without changing the basic, the feel. I actually will relate for the first time, well, I drove Seoul last Friday and it was amazing. It was quiet. It gave a great experience. I know we have a ways to go on suspension, but the fit and finish was wonderful. The comfort, you know, the basic, let's say, vision angles, looking out, looking in, reading the screen, the rear view mirror. It was much more than I had realized. Like, it's much further along in the elegance and the refinement than I thought we were. So I'm pleased to share that.
Wonderful. Thank you. Well, we're just closing in on the home stretch here. I think it might be helpful just to hear from Chris and Jason, possibly a little bit more on, you know, what's next, what's coming up, what can we expect, anything else just in wrap up, Chris, that you would like to share with our viewers, fans, investors, reservation holders, ambassadors, supporters. Thank you.
Of course, so many people on this call. We greatly appreciate your interest and you following intently what we're doing. Steve had to go and attend a California Air Resources Board meeting. So hopefully things are progressing nicely, both at a state level and a federal level, to make sure we achieve our, you know, environmental responsibility goals over the next decade. If the world is going to convert to an electric fleet, there's big implications all over the place. You know, just the amount of energy that would have to come from the grid to charge even 10% more electric vehicles out in the field would be very stressful, especially in a state like California. Wouldn't it be great if you had an electric vehicle technology that people could drive every day, but something that didn't tax the grid? Maybe a solar electric vehicle like the Aptera. If you take the power from the sun, you're not taking it from the grid. So we think that's an amazing attribute that will hopefully help garner us support from the federal and the state level. Some great things happening on tax incentives and the like, which I think people will be really excited about. With our base vehicle only being $25,900, those tax credits look mighty fine to get more people into Aptera. So that's a great thing. What's next for us is really progressing and putting a pin in the beta design. We've already started to release tooling for the beta builds, and we'll work on that throughout the summer, and hopefully be validating and testing those towards the end of summer, maybe into Q3. And then the idea is to take that knowledge and roll that knowledge into Gamma and Delta designs, which would hopefully be production intent by the end of the year. That obviously takes a lot of cooperation between our design partners and vendors, especially on the supply chain side. As all of you are probably aware, COVID has made for some interesting challenges, both on the internal resources, hiring people and getting people to Southern California from wherever they are, and on the materials front. Some just weird little things that I would have never thought would be a frustration for us. Metal to coat our battery management system boards, was delayed 6 weeks because of supply chain challenges. Some parts that we're trying to order for beta development. We were working with some partners in India on a few parts, and they've been, basically shut down the last few months. So the challenges are there, but we're still marching headlong into a great production plan. Monroe has been instrumental in helping us craft a great facilities plan and a production analysis of how the beta design is coming together. So it's been great to have Sandy and the Monroe's team's help as we analyzed alpha and then took knowledge and feedback from Monroe and put that into beta. So things like the body changes just get easier to assemble in a manufacturing environment. And they've done such great work for such big companies. We have infinite faith that they will really help us refine and fine tune our production methods. We're still looking for that perfect production property, and hopefully we'll be in a much bigger space soon to start doing a lot of that development work that just takes a lot of space. We've also been working hard on getting our next round of fundraising started. We're hoping to send out any moment now some information on how that round will start, and get you guys in to see what our new offering is about and how we're going to scale from here into a much bigger company over the next few years. We added Janice Burlingame to the team. She has infinite experience putting together IPOs and SPACs over the years. And she's just a great addition to the team as we start to plan for the future. So I don't know if we have any bigger overall questions, Sarah, but if there's anything that's really urgent, Jason and I or you could take a crack at it and then sign off.
Yeah, I think we're good. I think we have lots of questions, and as I said, we'll try to address as many of those as we can through our communications over the next week or two. We'll add them to our FAQ. We'll do some social posts. You're always welcome also to email us info@aptera.us with anything specific. We love hearing from you guys. It's very encouraging. We're working really hard and very long days and late nights, the entire team, and it helps a lot to know that you guys are all there, supporting us and thinking of us and giving us ideas. And we're just really thankful for that. So look forward to keeping you updated. Look forward to, keeping you posted on all the exciting news and announcements over the next couple weeks. So please check our website and, stay updated with us. And we will look forward to talking to everyone again soon. We'll be doing a lot more of these webinars up ahead as we get further. So thank you all so much for joining us, and we really appreciate it. We'll go ahead and sign off.
Thank you, everybody. Great stuff.